How do our cognitive processes change with age?
Hello.
Hello.
Thank you for coming in today.
You're very welcome.
We're going to be over here.
All right.
And how do older people like 79-year-old Joan differ from younger people on tasks that measure both speed and accuracy? Psychologist Roger Ratcliffe has developed a model for predicting and explaining cognitive changes as we age. And he says what happens is not as simple as some earlier models of aging would predict.
The older view was that old people slow. All of their processes slow at about the same rate. And so by the time you reach 60 to 75, you might be 1.5 to 2 times slower in processing.
But if true, that would place many older drivers at serious risk.
So in other words, if your braking time, if your time to hit the pedal is, say, half a second, old people would take a second. And I think if that was true, you'd see many more accidents on the freeways.
But Ratcliffe's model has demonstrated something different. Different because it doesn't just focus on speed. And the results suggest that older people do not automatically show a uniform decline across all of their cognitive skills.
Okay, so in this task, you're going to be seeing an arrangement of asterisks on the screen.
Joan's task will be to discriminate displays with many asterisks from displays with few asterisks.
And the computer will tell you if you're right or wrong each time.
She'll press one of the 2 keys with circles.
And you'll use this key if you think there are many, this key if you think there are few.
Then this is more, this is less.
Exactly.
Many asterisks is defined as more than 50, few as less than 50.
And we'd like you to try to go as quickly and accurately as you can.
I was told I couldn't count. That would take too long.
At first, like most seniors, Joan's very deliberate, as her desire to be accurate
Darn.
wins out over speed.
I think I wanted to be right all the time.
They seem to want to be much more sure about what they're doing before they make a decision.
Now watch 23-year-old Jess, who, like most subjects her age, gets frequent too fast messages.
Okay, you see those too fast messages?
Yeah.
Then that means that that wasn't enough time to make a real decision, so try to slow down just a little bit.
Okay. Tried to slow down every now and then when I got those too fast messages, but you get on a roll, you know.
So they go like a bat out of hell so they can get out of the experiment quickly. Usually they perform really well. They're trying to be accurate, but they're really motivated to get out. An older person coming in will try to be as accurate as possible. They really don't want to show that they're aging and losing it.
Most young participants are initially faster, while older subjects are often a bit more accurate. But older participants can be trained to go faster.
And you can actually speed them up to be almost as fast as young people in many kinds of tasks, and they're about as accurate. And then it stays constant across age. So for these simple kinds of tasks, it means decision-making is intact, even up to age 85 to 90.
But earlier cognitive models didn't discover this because they looked at only one variable, speed.
So it's like looking at voltage and ignoring current, which would be silly. In the old view, they didn't tend to do these manipulations of speed versus accuracy. And so what you found was this notion of general slowing in all components.
Now, when Joan is asked to memorize a list of individual words and is tested on them later, we find that she, like most other seniors, has also maintained her abilities even when asked to work quickly.
So old people may lose 10% by the time of recognizing whether a word was studied before or not.
But if we give Joan pairs of words to study,
And you're going to try to link the 2 words together in your head.
and then ask her later to determine if a different list shows the same word pairs studied earlier, then Joan, like most seniors, has problems that the younger Jess doesn't have.
You can see from this graph that performance has dropped to about 25 or 30% of the value it is for young subjects. So with age, your ability to recognize whether pairs of words went together declines rather precipitously. So different parts of memory decline at different rates as a function of age. And so our model allows us to put together the speed at which they make those decisions and the accuracy and come up with a single coherent account.
Ratcliffe's research has led to greater optimism about the cognitive skills of seniors, and down the road this may help clinicians treat a range of cognitive problems.
I think we're about one step away from practical applications in this. What we want to do is apply this to head-injured patients, you could look at things like concussion, you can look at people with different kinds of dementia, and try to come up with an understanding about what cognitive functions are affected by these kinds of problems.